Hello, my wonderful algebra students. Today, we're going to have another lesson on factoring quadratic expressions. We've already had 2 lessons on this, so hopefully everyone's feeling pretty comfortable with this. But we're going to continue. We're going to learn some new stuff about factoring today, writing expressions into factored form. Would you please have your book opened up to page 205? And on that page, we've got a warm-up. First thing says the product of the integers 2 and -6 is -12. They want us to list all of the other pairs of integers. They give me a product, an answer from multiplying, of -12. So I can't use 2 and -6. That one's already up there. Some other ones that I could use, I could have -2 times +6. Right? Because I already have the 2 times -6. I could use 1 times -12 or -1 times 12. Those both give me a product of -12. I could also use 3 times -4 and -3 times 4. I'm also going to list that one that they started us with, that 2 and -6, just so I can see all of my pairs here. All right, so of the pairs of factors that we found, I want to list all of them that give me a positive sum. Now, I wrote these as multiplications because we were looking at products, but now I want to take the pairs of numbers and find the sum of each of those. So the ones that would give me a positive sum, that would be like this, for instance, because -2 plus 6 would give me a positive 4 for my sum. In my 1 and 12 groupings, this would give me a positive, so -1 and positive 12. And then in my 3 and 4 grouping, I would use, I guess this one's also on the bottom, -3 and positive 4. And the reason why they all have a positive sum, I hope that you can understand this one, it's because the bigger number of those, just looking at the absolute value, the bigger number was positive. There were more positives, right? So -2 and +6, there's more positives with the +6. -1, positive 12, more positives in there. The ones that would give me a negative sum, well, it should be the other ones, right? So 2 times -6, and again, I'm going to go right to this explaining part right away because there's more negatives, right? 1 and, notice I'm not writing it as a product right now, -12. There's more negatives. I think I said negatives on the first one also. I hope I did. There's more negatives in both of those. And also here, 3 and -4, there's more negatives. That's why we would get a negative sum. The factoring that we've done so far, we haven't been dealing with numbers that have different signs. So that's a difference for today. All right, this table is still on page 205. It's giving us a couple of expressions that are in factored form and a couple of them that are in standard form, and we want to get the equivalent expressions. I want to change the factored form into standard form. I want to change the standard form into factored form. All right, we can certainly draw a diagram like it says. If you want to do that, you can do that. For the multiplying part, though, I'm hoping that you're okay with just doing our distribution, like FOIL kind of a pattern, right? X times X is going to give me X squared. And just to save some space, we're going to try to do the outer and the inner together. So this is going to be a positive 6x. And this is going to be a positive 5x. That gives me 11x. And then 5 times 6 is positive 30. Right? That's a pretty old kind of an idea that we've been practicing for a while now. The more recent thing is like the next one where I've got standard form and I need to change it back into factored form. So let's take a look at this one that I just wrote in standard form though and try to remember where these numbers are coming from. The 30 came from 5 times 6 and the 11 comes from 5 plus 6. So when I factor this next one, I know it's going to start with an x and an x. I know that because this is a plus, just like all the stuff that we did last week, that's going to have to be the same signs, and this tells me that both of the signs are going to be plus or positive. Now, I need to think of numbers that would multiply to be 30, give me a product of 30, and then add to be 13. Take a second, see if you can write that down, see if you can figure out what those numbers would have to be. Can't be 5 and 6. We just used 5 and 6, we got 11 there. So if I need to get 13, I think that's going to have to be a 3 and a 10. 3 times 10 is 30. 3 plus 10, 13. All right. The next one starts with factored form, getting standard form, and again, the same signs. They both happen to be negatives this time, or subtraction. So I'm going to get x times x is x squared. This is a negative 6x. This is a negative 3x, gives me a negative 9x. And then negative 3 times a negative 6 is positive 18. Again, the plus 18 is because they're the same signs, but the 18 came from multiplying the 3 and the 6. The 9 came from adding the 3 and the 6. Really, I should say negative 9 came from the negative 3 plus the negative 6. So let's factor or get this standard form into factored form. Notice that this one also uses an 18. So obviously 3 and 6 won't work for this one, but I can use my x and x. This tells me that they're going to be the same signs. This tells me they're both going to be negatives or subtraction. Now, I need numbers that multiply to be 18. And since they're the same signs, they have to add to be negative 11. So 6 and 3 don't add to be negative 11 or positive 11. But different numbers that multiply to be 18, that could be 9 and 2. If I use a negative 9 and a negative 2, that would work. And remember, it doesn't really matter if I put the 9 in this first set of parentheses and the 2 over here, or the other way around. It would be the exact same thing, okay? So if you turn the page to page 206, now I've got something different. I want you to notice, even in just the factored form, they're giving us a problem that starts with an addition and a subtraction, different than what we did in our last lessons, right? But let's get our standard form first. So x times x is our x squared. Here's a negative 3x and a positive 12x. What is negative 3x plus 12x going to give us? Well, that's going to be positive 9x. And then 12 times a negative 3 is negative 36. All right, look at this. All of these negative 36s, right? So I am looking for things that are going to be multiplying to be 36, because that's how I got my 36, was I did the 12 times 3. One of them was negative, that's why I got a negative 36. The fact that all of these are a negative 36 for the constant term, that tells me that I have to have different signs. The middle term, that linear term, if it's a positive, that means that the bigger number is positive. If it's a negative, that means that the bigger number is negative. So, again, this negative right here tells me that I'm going to have different signs. I don't care if you put the plus in the first one and the minus in the second one, or the other way around, does not matter. But this negative tells me that the bigger number is going to be negative. I'm going to have more negatives. All right, so I need numbers that multiply to be 36. 36 has a whole bunch of factors. If it helps, you can certainly make a list, right? I could have 1 times 36. I could have 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Having a list like that sometimes helps when we're not quite sure what numbers to put together, right? On this one, I have to have numbers that multiply to be 36, because they're different signs, it's a negative 36, and they have to really subtract to be that negative 9. Well, look at how similar this one is to compared to the first one that they gave us. I have all the same numbers, except in the first one, we had a positive 9x right here. That just meant that I had more positives. I had a bigger number with the positives. Now that I have a negative 9, I still think I can use 12 and 3. I just need to have more negatives. So this time I have to put the 12 with the negative and the 3 with the positive. All right, this one will not be using 3 and 12. However, look at this. Both of those are 35s. One of them's positive and one of them's negative. So if we can get the first one figured out right now, I think the second one's going to be pretty easy. So I need my x and x. I know that they're going to be different signs because it's a negative 36. What numbers multiply to be 36 and subtract to be 35? Well, I think right here we've got a winner. We're going to use 1 and 36. But I know that in this one, I need more negatives. I need the 36, the big number, to go with the subtraction. And the positive 1 is going to be there. Remember, you can always multiply the two factors together. Make sure you get the right answer. So the only difference between that one that we just did and the last one in this table is that I need to have more positives. It's still going to be 35. So I know that I'm going to have a plus and a minus. I just kind of tend to put the plus in the first set of parentheses, but you don't have to. But I need the 36 to go with that plus, and I need the 1 to go with the minus. Okay. So this says, name some ways that the expressions in the second table are different from those in the first table, aside from the fact that they're using different numbers. Again, in the first table, we had all problems with the same signs. Either when I factored it, I had 2 pluses, 2 additions, or 2 positives, however you want to say that. And in the third and fourth one, right here, we've got a minus, 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 right? That looks like an equal sign now, sorry. In the second table, we had 1 positive and 1 negative, 1 addition, 1 subtraction. Okay, so that's how the factoring is going to be different on this. All right, now we're looking at factors of 100 and negative 100. So this is still on page 206. So let's complete the first table with all the pairs of factors factors of 100, that would give positive values of b, and then the second one with factors that would give me negative values of b. So remember, the b is here. It's the coefficient for that linear term, the x, right? If I'm going to have a positive value of b, and I'm getting products of positive 100, that means they have to be the same signs, right? So when I'm doing this, I would, move this up just a little bit, I would have things like, how about 10 times 10? When I add those two together, I would get 20 right here. Other factors of positive 100, I could use things like 20 and 5, or 5 and 20, but when I add those two together, I'm going to get 25. I could also use, how about 25 and 4? The sum of those would be 29. And then I could also use, let's go 50 and 2 to give me 52. And let's go with 1 times 100. That'd be 101, right? If I want to be able to add my two factors together and get a negative answer, the only way that happens if I'm doing this is it's got to be negative numbers, right? I already found all of the factors. Let's just use that first table. Let's say instead of 10 and 10, we're going to go negative 10 and negative 10. When I add those together, I get negative 20. Then I'm going to have negative 20, and negative 5 gives me negative 25. And 25, negative 25 and negative 4 would give me negative 29. Negative 50 and negative 2 would be negative 52. And negative 1 and negative 100 would be negative 101. Right? The same table, it's just that everything in the second one is all negatives. But because they're the same signs, negative 10 and negative 10, when I multiply, I would get a positive 100. So that's all good. We're all happy there, okay? This one, I know it looks like a lot, and in your book, it doesn't have all three tables right next to each other. It's got the positive and the negative, and then underneath it's got the zero values of b. So if I want to be able to figure out for this, factors of negative 100, because it's going to be a negative, I know that I have to have different signs for my factors to get a negative product. So I want things like, let's try to get a positive b value. Let's use 25 and negative 4. So if I multiply those, I would get a negative 100, but the b value is positive because I've got more positives. This is going to be 21. Okay. How about 20 and negative 5? Notice I'm putting the bigger numbers as the positives here. When I add those two together to get a sum, I get 15. I can also use 50 and negative 2, which would give me a sum of 48, and 100 and negative 1, which would be a sum of 99. For my negative values of b, I have all of these different factors, and I got positive b values when the bigger number was positive. Well, what if I make the bigger number negative, right? So I could have negative 25 and positive 4. That would give me a negative 21 when I add them together to get my sum. Negative 20 and positive 5 would be a negative 15. Negative 50 and positive 2 would be negative 48. And negative 100 and positive 1 is going to be negative 99. There's one set of factors that I didn't use. And there's only one way to get a 0 value for b. I'm hoping that maybe you can see the one that's missing. The one that I didn't use is the 10s, right? If I had a positive 10 and a negative 10, when I add those two together, my sum is 0. That's the only one that can give me 0 for that. Okay, now let's use those tables and take a look at these 4 problems that we want to factor. We want to put into factored form. The tables are going to help us because I want you to notice all of these have a 100 with them. Letter A gives a positive 100. That's not in these tables. That's in the last table that we did. But let's try to factor these. X and X. This tells me that I've got the same signs. This tells me that they're both negative. What numbers multiply to be 100 and add to be 25? So don't think like you're going to use 25 and 4 just because the 25 is there. That's going to have to be 20 and 5. 20 times 5 is 25. And now notice it's not in the tables right up above here. This would be the last set that we did. They're the same sign, so I don't care if you put the 20 here and the 5 here, or if you flip-flop, right? It won't matter at all. All right. Here. Again, this tells me that I'm looking at these tables right up above it. I'm multiplying and I'm getting a negative 100. So I would have to have one that's a positive and one that's a negative, and I have more positives. So I want to look in the first table where I have a sum of 15. That's this one right here, right? So 20 and negative 5. So I need the plus 20 and minus 5. All right. Let's try this one. Again, this tells me that I've got different signs. One's plus, one's minus. This tells me I have more negatives. So I'm looking at the middle table, the negative value of b, where I get the negative 15 instead of the positive 15 is right here. So these are still my numbers, 20 and 5. But I need to have more negatives, so I'm going to put the 20 with the negative and the 5 with the positive. All right, last one. I've got x squared plus 99x minus 100. So again, different signs. I know that. It'll be an x plus and an x minus. And I've got more positives. So I'm looking at the first table. Right here is my 99. So I know I'm going to have to use the 100 and the negative 1. So plus 100 minus 1. Realistically, we don't want you to have to make all of these tables for every single problem that you have to do. We're going to just keep practicing at finding those combinations that work out. Oh, was that it? That was it. All right. So today's homework is going to be on page 209 through 211. We are skipping number 7, but I want to make sure that you can tell today when you're factoring what the numbers and the signs are telling you in a quadratic expression so that we can change it into factored form that would go along with the standard form, right? So if you're given the standard form with a negative constant term, you should know, this was the new thing for today, negative constant term, when that B was negative, when the C was negative, when the last number is negative, how to factor that. That's where we're going to get things that are x plus and x minus. All right, if you need any help with this, feel free to reach out.